Hi, I'm Gary and welcome to my shop. In this video I'm going to show you or talk about this trend Airshield. I had a good year, so I decided to treat myself and get one of these as they're supposed to be so good. You may have seen in a previous video that I did how I did this bionic UVEX face shield along with this dust mask, and I made this deflector so that it would not fog up the inside of my face shield. That worked fairly well for a good time, and still does, although I didn't realize exactly how much that does not filter until I tried out this shield. So I had to go with this. I'm not going to give a review or setup and use because there's a lot of videos out there on that already. Primarily, what I'm going to cover in this video is about the battery in this. It's a nickel metal hydride battery, and I'm going to talk about how to charge this battery and to maximize your life out of it. Now, I do a lot of RC aircraft, and I'm used to using a lot of rechargeable batteries for those, mostly along the LiPo range. And some of those batteries are expensive, $150 and up. So I'm very conscious about the price of my batteries and maximizing the life out of my batteries. So I came up with some hacks on how to charge this battery while it's in the shield through the charging port that's on here, and using my charger that I use for my RC radio batteries. And there's settings on there for Ni-cad, nickel metal hydride, LiPo, and so forth. And it has a computer board in it, so it's a smart charger, and it'll stop charging when the battery is full. Unfortunately, with this, it comes with this little wall plug-in charger that I don't know if it's a smart charger or not, because the instructions don't say anything about that, if it'll stop charging once this battery is full. I did notice that when I had the charger plugged in here, that if it was not connected to the helmet here and plugged in for the battery, the light on it was green. Once I plugged it into the helmet and started charging it, the light turned red. So I don't know if that means it really is a smart charger or not. I did finally have about almost 24 hours of charging on this, and before the 24 hours was up, the light on that charger turned green. So I tested it with a multimeter, and it came up with the I think about 4.35 volts, which is a full charge for that battery. So, not having enough information to know for sure if that's a smart charger or not, I still decided to go ahead and kind of engineer my own charging system for this. This is an idea you can adapt, because the chargers for this kind of thing is about 50 bucks, which compared to other charging things that they have for this or accessories and the cost of the batteries, that could be a very cost-effective way to go, is to get one of these chargers, because you know that your battery is going to be charged correctly and not overcharged. Now, there's a lot of other kinds of smart charger out there on the web, and a lot of them look exactly like the one I'm going to be showing you here. So you kind of pick and choose what you want, but make sure it'll at least charge nickel metal hydride batteries and not just LiPos. Stay tuned here and I'll show you how I do this. In my effort to try to find a better way of charging this battery in this trend Airshield so that it won't overcharge or cook the battery, so I tried to find a tip that would match this one off the trend charger. And I came up with this one that I found that is from a different charger that I use for other kinds of small devices. I found this one to match, and I found that the outside diameter of this is about 5.5 millimeters, and the inside diameter of the tip here is about 2 millimeters. So that's the kind of tip you want to look for. Then what I did was to try and find out what is the polarity of the original charger. Is the tip inside there a positive or a negative polarity? With a very, very strong magnifying glass, I looked at the adapter that plugs into the wall, and it showed me that the polarity of the tip is a positive polarity. It's an important thing to know. So what I did on this one was I needed to figure out the polarity that this tip is and which pin that is. So the inside of this tip matches with this prong here, which is on, the left side of this. And I marked that with a little red dot to help me identify it, because I'm going to be soldering some wires onto here to create a plug-in for my battery charger that I use for my aircraft batteries. To test that, what I did was use the multimeter and set it to an ohm setting, plug one part inside the tip, and then I checked the various prongs to find out which one gave me a zero reading on the ohms. The other tip has resistance. so that's not the one. This tip is. So I marked that with the red spot. Then, to test that this made a good fit, got the battery in the shield here, and I plugged it into this, and I want to make sure it's making contacts on all points on that. So now I'm going to switch to volts. The left one here has got the red dot on it, so that's the positive, and I'll touch that, and then the negative on the other end, and it gives me 4.3 volts there. So I know that this tip is making good contact in the helmet, so I can use it for charging. Next, I will find a suitable cord that will plug into my charger that I can wire this up to. So this is the charger that I usually use on my aircraft batteries for my RC control airplanes. And what I want to find is a cord that the banana clips that will plug into here for providing the power. And I've got this assortment of different cords and plug-ins for a variety of different kinds of batteries. Found this one here that I think is for gas-powered airplanes. I know I never used this particular adapter. So what I'm going to do is snip this off, and then I'll solder these wires accordingly to polarity to these prongs on this adapter. And then I'll use some like shrink tubing to seal this all up with to make sure it's secure. Okay, so here I had cut off that end off of this connector, and I soldered these wires to that adapter that I was showing you before that fit the Airshield Pro helmet for the battery charger port. And it's careful to be sure that I've got the negative on the negative side and positive on the positive side, as I've marked by the red dot. And then what I'll do, I've got these shrink tubes that I'll just slide up on there. And then I can use a heat source, like a cigarette lighter, or you can use a heat gun, just to get these warmed up a little bit so they shrink down and get a good grip on there. Doesn't take very much. They just kind of tighten on there very well, and they'll stay on there pretty securely. Now I've got an adapter to use with my battery charger that I use for charging my airplane and helicopter batteries, because this has settings in it that will allow me to charge Ni-cads, the nickel metal hydride batteries, lipos, life, pretty wide range for all the batteries that are out there today. On my charger here for the settings, I've got this set to nickel metal charge. Consult with your charger's manual for settings that are specific to your charger if you got one of these, or if you get something from online, and it'll have instructions on how to set up to do the nickel metal hydride charging. Anyways, this charger that I have here has a computer board in it that controls everything and automatically senses a lot of things, so it makes it very convenient and a lot less programming to do. Now this charger will auto detect the voltage and the number of cells, and I set the charge rate for my first use to be half of the battery's capacity. In this case it's 3.5 amp hours, so that's 1.7 if I set it to half. In the future I may elect higher rates to a maximum of 3.5 amp hours, which is a 1 times charge rate. A 2 times charge rate would be 7.0 amp hours, and that would be a fast charge. I don't know yet if this battery will accept a fast charge without damage. Some of my RC airplane batteries, some of them I can do a fast charge on them, and others I cannot. It's identified on the batteries, in those cases, what charge rates I can use. So this one doesn't have it, so it's an unknown factor. To be safe, I'm going to go at half to start with, and then a maximum of 3.5 amp hours in the future. Anyways, to set the amp hours, you can press this on this particular unit anyway. Then I can increase the amp hours or decrease them. I've got it to 1.7 there, so I'll press enter in order to set it. And then, once I have all the settings in, I'll press and hold this green button until it beeps, and that starts the charging progress. I'm not going to do it now because I don't have a battery connected to it. Now, this one will automatically stop when the peak voltage is reached, and this will prevent overcharging. As I said, this has a computer board circuit in it. It's a smart charger, and it will stop once the peak voltage is reached, so you don't have to worry about overcharging. There's other chargers you may buy online that will do the same thing. There's a lot of them out there that look exactly like this one. They're about $50. Depending on what uses you have for it, this might be a good option to do, especially considering the cost of batteries for this Trend Airshield and other charging options that they have for this battery. This seems like a cost-effective alternative, especially if you can use it for other kinds of batteries. Well, thank you for watching this video. I hope you enjoyed it and got some inspiration. If you did, please give me a like and share it with your family, friends, and fellow craftspersons. Also, please subscribe to see what I may come up with next, and remember to hit that bell icon so you won't miss out on anything in the future. I also greatly appreciate all your comments. I get a lot of good ideas from all of my viewers. As I say, if the ladies don't find you handsome, at least they should find you handy. Thank you.